All right, what I'm going to show you here quickly has nothing to do with this class, but I wanted to make a point to you, okay? The afternoon class, I had them watch this video by themselves the other day. And it's a Brad Traversy video. He likes Breaking Bad, so he made this thing where he goes out to API. Breaking Bad has its own application program interface, its own program, basically. And he made this. He's got all the characters there, and when you put, like, this is Walter White, etc. When you put, or Junior, when you put your mouse over it, it twirls, etc., and it gives you information. So why am I telling you this? Well, what I asked the students to do was to go through this, take a look at it, and I'm taking for granted that if I mention, if I say to you something like a website mashup, you understand what I'm talking about. All right? So I asked them to take this and use that kind of as a template, and then go out and I found a really simple API, and that is, these are about 20 quotes from the TV show Friends. And I asked them to mash the two up. Okay? That's literally their assignment. And when they did their evals, like you guys did, they complained and said, we haven't done really anything. You gave us an assignment for teamwork. Well, unfortunately, when I gave the assignment for teamwork after the first day, there's only 4 people in there, so it's 2 and 2, and one of the people got COVID. So the one team was down to 1. All right, so they kind of complained. So I said, well, then do this assignment and do it in teams. So why am I telling you that? Because in a way, what we're going to look at right now, for lack of better words, in a way, it's a mashup. And what I'm saying is it's a combination of what is shown in one of these articles that I gave to you that's called A Guide to Object-Oriented Programming and in JavaScript, and a different thing made by Brad Traversy, which is his JavaScript OOP crash course. Now, my guess is whoever wrote this article, all right, in 2019, saw what Traversy did on his and based a lot of their examples off of the article. Does that make sense? All right. So I'm going to go through this. I'm not going to go through a lick of his thing. All right. I'm not going to go through any of this stuff. I just wanted you to see that. And if you go and open up the first thing that I gave you, that's this folder called OOP, literally, when you take a quick look at it, I'm just going to bring this up, there's nothing in the HTML. You see that? There's nothing. All right, except the reference to the JavaScript file. All right, and let's see, do I still have that up in here? Yes. Okay, so the main file, as you'd probably guess, is the JavaScript file. So if I bring this up, and I've already got it up, but I'm going to show you this. I've already gone through this, the 4 pillars of object-oriented programming. So I copied that information and stuck it out there. All right? I'm not going to go through a bit of it because we did that right before the break. All right? This is the URL for that Brad Traversy OOP crash course. What I like about what Traversy does is, first of all, he's one of the most intelligent people I've ever heard in my life. Second of all, he has a tendency to put things in a way that are understandable, which I like. All right, and third, when he creates these crash courses, by and large, they're usually around an hour. This one, I think, is 40 minutes. Do you have to look at it? No. But what I am going to do is I'm going to run through many, not all, but many of the examples that are in here and use them in conjunction with this article. So I'm kind of mashing the two of them up, is what I'm telling you. All right, so let's take a quick look in here. The author mentions it all starts with an object. Basically, it's called object-oriented programming. So these are things that you should at least have an understanding of. Now, that said, for right now, this is the first day we've ever gone over this. Don't worry much about association, aggregation, and composition. We will look at them, but don't worry about them. But the expectation will be when you take your test, which is not next week, or it's either at the end of next week or it's the following week. I don't remember. I think it's a week from Monday, but regardless, you will have to understand how to create objects. You will have to understand how to create a class or more, one or more classes. Those classes will have properties. Those classes will have methods. You will have to be able to instantiate or create objects based off of those classes. When you do that, you will be using encapsulation, abstraction. You will be probably asked to do inheritance. Think about how you would do inheritance. I've already given you example to just kind of to try to reiterate it. All right, let's say that I create a class and I call it bank account. All right, don't worry about what kind of bank account it is, but all bank accounts, to my knowledge, have a number associated with them. They've got one or more people who can use that account, and it's got their information. Would you all agree with that? But the way that I would do a checking account is much different than the way I would do a savings account. All right? And even with checking accounts, there are typically interest-bearing checking accounts, and there are non-interest-bearing checking accounts. There's IRA accounts, there's Christmas Club accounts, etc. And the only reason I'm saying that is, again, you start coming up with what are typically called object-oriented hierarchy diagrams. So I've got a bank account, and I'll just make this checking account. This will be savings account. Let's just say this is an IRA account. All right, and let's say this is a Christmas Club account, something like that. And then in my checking account, I can have interest-bearing, and I can have non-interest-bearing. So what you're starting to see there is an object hierarchy. You can do that with almost anything. You can take the example, I'm not going to put it up, but the one I put up there before, that had animal, cat, dog, and fish. We could break dog down, right? How many breeds of dogs are there? There probably are. If you told me there's 100, I'd believe you. All right, so you can keep breaking things down. So I'm only probably going to have you go down to a couple levels like this. This is actually, believe it or not, there are 1, 2, 3 levels. But again, remember, we're computer people. So this is level 0. This is level 1, and this is level 2. So this would be referred to basically as a level 2 object-oriented programming hierarchical diagram. All right? So you won't have to produce that, but you'll have to create something like that, probably to about that level. All right, maybe it'll only be to that level. I don't know. I haven't written the test yet. I still haven't graded your other tests, and some of it's going to be, I'm going to see how people did on that last test. All right? Okay. We also mentioned polymorphism. But again, you don't have to be concerned with association, with aggregation, and with composition. All right? So, you've already seen this. This is an object literal. So again, what I'm going to do is I'm going to try at least. Let's see if I can do this. I should be able to. I'm not that uncoordinated, I don't think. But I should be able to come in here and put this up there and also come in and put this up there. All right. Don't need that. There. All right, move this over a little. So you can kind of see my mindset as I was doing this. I mentioned this to you earlier, that if I run the code that's highlighted right there, it's going to literally show on the screen string, then underneath it it'll say object. So it considers the first way that we've created that the, quote, natural way, unquote, to be a real string, and the second one to be an object. All right. Again, there are a lot of built-in objects in every programming language, and JavaScript is no exception. If you come in here and you were to type that in, again, I can go, if you want, we could uncomment this and run through the whole gamut here. But if we do that, it's going to take the rest of the period. I want to be done around 10:15 or so. Okay? But there's a window object. And if you open up that window object, what you're going to see is it's probably got 50 things underneath it. All right? The window object is a kind of an innate object. So you can use it without having to use the word window. And that's what's shown in the examples underneath it. We've used alert many times this semester, but we could have said window.alert and it would have worked just fine. All right. There's other objects, such as the Navigator object. If you run that, it's going to literally, and again, you can say window dot or without, all right, but it's going to show you information about your machine. Okay? So, why am I showing you that? Because now we've got basically up to where they are right here. All right? So this thing is referred to as an object literal. I made 3 of them. Okay? So I made 3 books. I actually went out, double-checked, and thought I knew the authors of all 3, and I did. Had absolutely no idea when any of these books were written, so I went out to the internet and found that a little earlier. But what we are doing right here is we are using what are referred to as object literals. All right? Now, one of the, quote, bad things about doing this is what if this was an entire library? And what if I had 20,000 books? I really don't want to make 20,000 of these. Not that that couldn't be done, but that would be a heck of a lot of work. But especially, if you're working on a small project, this is the way a lot of people still do things. All right? So when you look at it right there, what is it? Const, could have been a let, but typically it'll be a const. The name of the object, which is book 1, and these are the components. All right? I don't know why I've got commas after each one of these. I think it still works with the comma. It's kind of like putting the semicolon after the last thing that you put into a CSS file. I think it still works, but I don't know why I've got commas there. All right, I think it's copy and paste, but that's fine. So we've got 3 different objects. Every object has the same 3 properties. They all have a title property. They all have an author property. They all have a year property. Okay? So I create all those, and then as you'd guess right here, I can console log them out. And if I do, it's going to show me the information about each one of those. What you may or may not know, and I asked this before, James answered correctly. So if we look at this example here, there's an example of how we can print out one of the properties. If you just print out the name of the object itself, it's going to show you everything. And actually it'll show you, it's in curly braces, but if you open it up, it'll show you everything that's in there. All right? And this is how you can print out the individual things. Every object has 2 different types of things. So if, for example, if I say console.log object.values book 1, when you look at this, line 106 here, that's going to show me A Christmas Carol, Charles Dickens, and 1843. Those are the values. The one underneath it, when we ask for the keys, that's going to show me title, author, and year. So you can print it out collectively, you can print out each piece, and you can print out whatever you want to print out, in other words. But again, so this is using an object literal. As it says, create a new object in JavaScript by setting its properties inside of curly braces. The literals can be any data type. So you can have functions in there, you can have arrays in there, etc. So that's the example that they create. And again, after creating it as it says, you can get to the value using dot notation. So that's pretty much everything for that. All right? Then we've got an object constructor. Look at the difference. This says const book. This says const book. This has got title, author, year. This has got title, author, year. All right? Doesn't look like there's really, it says it's the same as a regular function. It will be called whenever an object is created. Well, again, typically you'll add other stuff into here. All right? And notice, for example, they did not put a comma here. They did put one there. See that? So it really isn't going to matter. What happens in here, and you hear the same thing if you were to watch the video by Traversy, is he gets to a certain part and he kind of laughs and he goes, you probably already realized I've shown you about a half dozen ways of doing the exact same thing. And that's what they're doing in here as well. So, it says if you want to create multiple book objects, we have to duplicate the code for each book. We've already talked about that. That's what's kind of poor about using something like this. All right? Now, every object in JavaScript will create from the master object, as I showed you. That's with a big O, and that's what's at the top of the hierarchy. All right? So in other words, where they've got something like this, they'll say later, they'll go class book. Okay? And then you don't say this, but you could literally say extends object. That's redundant to say because that's what's happening behind the scenes, but you could say it. All right? And that's basically what they're just mentioning right here. So this is yet another way. Well, now, when you start going through this, this is some of the stuff that's in here. All right? So you'll notice it's of type object. There are no arguments being passed, and there's a bunch of other stuff. And I'm not going to lie to you, the majority of the stuff in here, I don't know what it does because I've never had to use it. All right? You can look it up if it's something that you're interested in. All right? So you can use object.create with this. So let's look at what's different here. Okay? So what we're doing here, technically it's not a class. We're not using the word class. It's a variable that's called book, and it's got this summary function in it. Then we actually create a book with object.create of this type, which means it already has available to it that summary function. That's what it means. All right. Then we add to it an author, and we add to it a title, and then we call in here, and I should have hit enter there, we call in here the summary function. All right? So what is that going to say? It's going to say Hippie is written by Paul Coelho. Does that make sense? All right? You're probably not going to see this type this way often. Not that there's anything wrong with it, but for lack of better words, it's a little bit clunky to use. But again, there's nothing wrong with it. And just to show you, again, I put examples of that in here. This right here was to show you that when you create, if I were to go right now and take these lines of code, just these lines that are in here in blue, and if I uncommented them and ran the program, I'd get a message in my console log that would say new book instantiated. Because whenever I call a new book, it always calls the code in here. Even though there's no constructor in there, it would call that anyway. That would be a poor way of writing it, but it would work. There is no constructor in here because this is not a class. This is a function. All right? So this is where it gets, in my opinion, more up to date. They talk about classes. Now notice, you've heard me say this umpteen times already today. A class itself is not an object. It's the blueprint of what objects are to look like. All right? So when we go in here, this is a little confusing. All right? Sorry, I didn't make it up. But this is the way you used to have to do things in here. So notice, again, maybe I'm missing it. I don't see the word class in there. All right? And I'm talking about this example here. So let book equals, it's got a function. Basically, that whatever name you pass in, it sets the name. So this is new book. Now this is confusing. This is the way you used to do the equivalent of inheritance. Because notice what this says. This says, I got a new book, all right, and I want you to call this. So that's the book.call. Many people hated this type of syntax and found it really confusing. All right, there's nothing wrong with doing it that way. And then notice, new book.prototype. there was a lot of work you had to do. What's the old saying? There was a lot of bang, but very little buck. No, a lot of buck for very little bang. That's what it is. Now, when you look at this, this is more the new way of doing it. Again, let me hit enter here. All right, and let me hit enter here. So look at this. We've got this. So every time you create a book, it will have to have a name passed to it. Does that make sense to everybody? All right. Then this says that new book. So when you use this syntax, it's class, child class extends from parent class. So in other words, a new book is a book. And since it is a book, you have to account for what gets passed to the book. So notice how you do this. You say super. You do it pretty much the same way in Java. Super means call the parent. So the first thing you want to put in your constructor, the first executable line, is a call to super. And if we had in here, let's just say title, author, and year as an example, we would have said super, and we would have passed in all three of those. All right, and this is important enough that I'm going to see. We'll see real quick. Hopefully I can copy this. And like I said, I just want to make sure you get this. So I'm going to change this. And I'm going to add a couple things to it. So I'm going to assume that we've got a title, we've got an author, and we've got a year. Okay? So I'm going to come in here and make 3 of these. Typically, you still see the curlies all over the place here, just like this. And now we'd have to put in title, author, year. Whoops, year. All right. So we'll still need all of these. All right. Now, I'm making this up literally right in front of you. We're going to assume that the new book also has a thing in it that's called review. Hear me? I'm just assuming that right now. So I'm going to come down here and I'm going to say this dot review equals review. All right. So constant new book. I'll just use the stuff that we had before. So I'm going to put in here a Christmas Carol. Charles Dickens. I think it was 1843 or something like that. I don't remember. And we'll say, I'm going to put this over multiple lines just so you can see all of it. And we'll just put in here for the review a Christmas classic. So when we do this and we call it like this, the system says, okay, first of all, is this thing expecting 4 things? There's 1, there's 2, there's 3, there's 4. That's good. So that part passed, so to speak. And it says, okay, we have to pass the title, the author, and the year over to here. So all of this stuff gets sent here, but then it gets sent up to there to be handled. All right? Then this has got to be handled in here. Does that make sense to everybody? Because that's basically what you have to do with inheritance. Now, if we had another thing, I'm not going to make another level, but if we had another level, all right, super could call super, which could call super. All right? And this can be, again, as many levels deep as you want it or need it to be, all right, in order to do whatever it is you have to do. So it says class syntax, this is the verbiage I used before. It says it's syntactical sugar. It still does something like this behind the scenes. But you don't care. I don't care. And if you tell me that there's two different ways of doing something, and one way is much more intuitive, and it will involve about the same amount of code, I can tell you right away which one I'm taking. All right? All right. So, again, that's similar to the one I just showed you. It's a little bit different. So, encapsulation, again, means hiding information or data. Now, there's two words here that you have to understand with this. All right? And basically, let me show them to you. They are this and this. Whoops. All right? And again, using as an example the same one I gave you before, the calculator. All right? This is the interface. So the interface is what's typically what you make publicly available to the world. This, when I put in 569 and I click this 2x thing and I get that, all right, I'm not even sure exactly what that is. I don't care. But the implementation is how that happened behind the scenes. So as a programmer, you're typically, if you're a web developer, you're paid for both. All right, but if you're doing a lot of application programming with C# or Java or whatever, it's almost all implementation. The interface, typically, you don't care. There might be very little interface. There might not be an interface. You might be providing something that's going right to a computer. All right? But the idea is, and I think I spelled that wrong, you have to be able to understand the difference between those two. All right? What you end up encapsulating is not the interface. You end up encapsulating the implementation. All right? You don't want to show that, make that available. Now, and again, you might say, does it really matter? It may or it may not. First of all, what if you made it available? And somebody came in and said, you know what, I got a better way of doing square roots. So you let them rewire their calculator or do whatever, and now they break it. Now they come to you and they go, this doesn't work. All right? But think about it this way. Let's suppose that some really smart, astute mathematician comes up with a new way of doing square roots. And what they do is when they start putting out new calculators, they now implement that. It still looks the same, but the implementation has totally changed. As long as the interface doesn't change, as an end user, I don't care. And let's face it, if I put in a number and I click square root, if it takes me 0.3 seconds or 0.1 second, doesn't matter to me. All right, I'm probably not watching when I do it anyway. But again, depending on the application, that can be unbelievably important. All right, so you encapsulate the implementation for two reasons. First of all, oftentimes it's proprietary stuff. And the other thing is you can now change the implementation if you come up with a better way of doing it, and as long as the interface doesn't change, who cares? All right? So as it says, abstraction means kind of what I just told you. Implementation, hiding. It's a way of hiding the details and only showing the essential features. Now, I love this. In other words, it hides irrelevant details. That isn't true. It hides basically what makes the thing go. All right? Think of a human being even. You sit there and if somebody's having a hard time, let's say they got a cold and somebody comes in like this, I can hear them breathing, yet if something different has changed in their heart or whatever, I can't see that. All right? All right. And as it says there, inheritance then is a mechanism that allows you to create a new class based on an existing class. It says generally, JavaScript is not a class-based language. Well, as of ES6, it is more of a class-based language. All right, but still, underneath the hood, it remains prototype-based. Again, do you have to care about that? If you're going to use the new way of doing things, you don't have to. So jumping back to this, all right, notice I came in here and I added that function. Okay? And now I come in here and I create a bunch of these. This is that older stuff with the object.create. So take a look at it if you've got an interest. Now, this is what I wanted to get to right here on line 174. Why? Because it's changing now. So we've got a book, and we're assuming that all the book has in it is a title. That's it. All right? So now we've got a magazine that extends book. Well, I put in here month and year for the constructor. All right? But I'm saying super title. I guess this wasn't complete because I'd have to come in here and say this dot month equals month, and this dot year equals year. You have to provide for all of these. What differs is how you're doing the providing. Now, I might come in here and maybe year does get passed into this, and I put a year in there. But notice I made a book and a magazine. All right? And this, Traversy does do this in that video. But magazines typically come out monthly. Not always, I get it. It doesn't matter. All right? A lot of them that used to come out monthly don't anymore. I get that too. But I'm assuming here that one of the differences between a book and a magazine, in fact, let's make it like this, because then it'll look more like the other one did. All right, we'll just put year there, and I'll take year out of here. All right, and I'll grab this one right here. And I'll say that. So in other words, what we're saying now is for a book, what we expect is when you create a new book, just a book, it has a title and a year. When you create a magazine, which is a child of book, you've got to give it a title, you've got to give it a year, and you've got to give it a month. But the title and the year are going to both be handled by the parent. Does that all make sense? All right. I mean, I decided to do it like this. I went back and reread the chapter yesterday, and I don't think that a lot of the examples that they have in there are great for what they're trying to say. All right. And I figured that showing you a bunch of this would make more sense than doing it the other way. Maybe I'm right, maybe I'm wrong. I don't know. But notice now in here, what do we have? All right. Well, we've got a title. We've got a year. I guess I did them in reverse order, so that should be 2020 there. Now, if I did that the way that it was, it would assume that the year is May and that the month is 2020. You get that? All right. And since JavaScript is such a forgiving language, it's not going to grab that, flag it, or do anything to it. Okay? All right. And just to show you on this next one here, it's a lot of the same, but forget about the magazine for a second. There's a book. All right? This is the constructor right here. Notice it's within curly braces. We also have the curly brace here that ends here. Does that make sense? Because this particular class has both a constructor method and a summary method. All right? And again, it's not that this is that fantastic, but just to show you that typically a true class has both properties and methods. That said, it's possible to create a class with properties and no methods. It's possible to create a class with methods and no properties. All right? And again, typically, when you go back, like we just looked at, and you would do the extends, and that's the same exact word that's used in Java, just so you know. You do it the exact same way, so that line would work in Java as well. All right? But typically, when you are going in and you are extending a class, you will give it new methods and or new properties. You might give it both. You might give it, just one or just the other. All right. That's pretty much it from there. So let me jump back into the article here. And their examples aren't going to be that much different from mine. But notice they have both prototypical inheritance. So this is non-class based. Did you hear me? There's the word class is not in here. This is the way you had to do this before 2015, 2016. And it's still the way that it's being done behind the scenes if you're using the newer ES5, ES6 way of doing it. But the newer ES5, ES6 way of doing it is typically easier for people to understand. All right? Okay. Again, we've talked about polymorphism already, but notice the ability to call the same method on different objects and have each of them respond in their own way. I would change that to have each of them respond in the correct way for that type of object. All right? It used to be, many years ago, I remember when I was at Blackhawk, and probably I hadn't been there that long, they asked me to teach a class on Excel, which assumed that I knew it, but I did a little bit, and I went out and learned some more. But back in those days, you literally, when you printed out charts and graphs, etc., you had to do the printing differently than you'd print out a regular spreadsheet. But with both of them, you called the print command. You had to set a few features to print out charts, etc., but after you got done, you still said print. That was polymorphism. They were two different types of objects that were both responding to the same method. All right? All right, let's quickly jump through these. Now, this, believe it or not, almost gets you into the world of databases when you start talking about associations. We are not going to do databases in here. What I've decided I'm going to do, and, I don't know if this would have helped you guys last semester or not helped you, but I'm going to start it during the break, but we're going to write a complete payroll system from scratch. And we're going to incorporate something in every chapter that we have in the book. And eventually it'll have classes, it'll have database functionality, etc. Now, I'm not saying it's going to be the best thing in the world or you're going to want to sell it to somebody, but it's meant to demonstrate everything that we've been talking about. All right, so we'll start real simple, and when we get done, it'll be pretty decent, hopefully. All right, but when you start talking about databases, it says it defines the multiplicity between objects. One-to-one, one-to-many, many-to-one, and many-to-many. Again, this is not symbolic, similar to databases. All right, let's assume that I've got about 20 pieces of information about a person. First name, last name, address, city, state, zip, cell phone, etc., all this stuff. I've got 20 pieces of information, and I'm going to put it into what I call a database table. But I decide that that's too many pieces of information. I don't want 20 pieces. So I break it up into two tables, and I put 10 pieces in one and 10 pieces in the other. Is that clear enough that it makes sense to everybody? Okay. Now, there's a one-to-one relationship because I could take those two tables and combine them back together into one. And for every one thing in one table, there's one, for every one person, there's one thing in each table. That's a one-to-one relationship. Now, what some books will do is they'll say, it's kind of like the relationship that you have between, man and woman, man and man, woman and woman, whatever. It doesn't matter. All right? But, typically, like when you talk about marriage, that's a lot of times what they say with one-to-one. All right? And then, typically somebody always raises their, well, what about Utah? But it's ideally, at least, I shouldn't even say ideally, the way it's typically set up is you have a one-to-one relationship between husband, wife, wife, husband type of an idea. What you would like to do with all of your relationships is have what's called either a one-to-many or a many-to-one. They're the same relationship, it's just where you flip a one-to-many and it's now a many-to-one. Does that make sense? All right. But if I look at it this way, and let's say that I have employees here, and here I've got departments, and I say that, so I've got accounting, receiving, and shipping. All right? And each one of these departments can have 0 or more employees. Does that make sense? If I just create a brand new department, it doesn't have anybody in it yet. All right? And maybe now I don't have departments. So I've got 100 employees, so boom, I just got 100 employees. But now I break them up, and when I get done, I've got 30 in accounting, I've got 30 in receiving, and I got 40 in shipping. I'm making that up. So that would be a one-to-many relationship. So each one department could have 0 or more employees working for it. And again, the only difference between a one-to-many and a many-to-one is which one you're listing first. All right? Now, sometimes you've got many-to-many relationships. Rankin is an example. What does that mean? Well, think about it. Courses, students. All right? Any one student can take 0 or more courses, and any course can be taken by 0 or more students. Typically, especially when you get into talking about databases, this doesn't work. A many-to-many relationship doesn't work. So you break it up. I don't even want to get into it right now. All right, but I just wanted you to hear that there is a natural tie-in between what they mention here for association and what you and I would consider for something like databases. All right? Okay. Aggregation says it's a special case of association. In a relationship between two objects, one object can have a more major role than the other. In other words, when an object takes more ownership than another, it's a has-a type of relationship. All right? And a lot of times when you start breaking up these things to find, for example, let's say that I was going to create that car. Would you agree with me that a car would probably be made up of a lot of other classes? For instance, there could be an engine class. All right, there could be tire classes. All right, and we come up with a lot more. All right, so there would be an aggregation between car and tires, for example, or car and engine, because a car has an engine. It's a has-a type of relationship. All right, so we talked before about inheritance, and that's an is-a type of relationship. Aggregation is a has-a type of relationship. And then finally, you've got composition. And kind of the standard way of looking at that, all right, is think about, so let's say that I made a class that was called clock. And I would say that, basically, well, what would it have for properties? Well, it would have an hours property, a minutes property, and a seconds property. All right? Maybe not even a seconds property, but let's just assume that it does. And for methods, I would want to be able to set the time, set the hours, set the minutes, set the seconds, etc., all that kind of stuff. All right? So I get all that, and it's working just fine. Somebody else says, well, what about an alarm clock? Well, isn't an alarm clock a clock first and foremost? So I could go and take that clock class that I made, and I could put it in as one of the members in my alarm clock class. So literally, when you basically take a class and make it a member of another class, you're using composition. All right, that's not the best example, but it's one at least that works. All right. And they've got this composition over inheritance, etc. They'll give you this stuff. All right. So the idea, like I said, behind this was this is getting you starting to think in this mindset. All right. So when we look at this, I want to do two more things, and we're going to be done in about 5 minutes. But to show you quickly, so this is what's in Chapter 16. How to create object literals. You've already seen that. All right, we'll still look at their examples. How to extend or modify an object. All right, we'll look at that. They use the miles per gallon one. I don't think that this is an effective one that they use in here. And they use this trip apps. I don't think that's an effective one. It's not that there's anything wrong with it. It's just, for lack of better words, I wouldn't have used these. I would have used different examples. So we will go through those. All right. And the other thing, I sent you all those URLs. Again, you can look at them, not look at them, use them, not use them, totally up to you. All right. But all that said, then I went back and sent you another thing. I found this. I was out looking yesterday online, and I found this. This is by, I'd never heard of him before, but Well Paid Geek. And it's a 3-part project. And this is where I'm going to pick it up tomorrow. Because I'd like to literally take maybe a half an hour, 10 minutes for each one of these. I don't know. But notice it's first object-oriented programming, the basics. And he writes a program and he says, I'm going to use not JavaScript. And you're like, well, wait a minute, this is JavaScript. Yeah, but he does this in a different language, in PHP, because he wants to show you how a more object-oriented language that's more strict, I wouldn't have picked PHP, all right, then JavaScript could be used. All right. Then he explains everything that's happening, and that's fine. Then he goes into talking about objects in JavaScript. All right. And he says basically that even if you were to write this, okay, if that was your whole program, so you come in here and you go function foo, all right, and you put nothing in it. No, it has no parameters, and it has nothing inside of it. You can go into the console and you can type foo.prototype. Who cares? Well, what that shows you is even that function is an object because it will have different properties that are associated with it. That's what he's trying to show right there. All right. So then he comes back and he rewrites his original example like this. And this is where I'd like to pick it up tomorrow. All right. I literally, when I say gleaned, I stole his code. All right. And I want to go over that because he does a nice job underneath this of explaining everything that's happening in here. All right? And I think the more examples that you get, the better off you are. All right, then comes part 2 of this. He says, okay, now let's talk about inheritance. And he comes in and says, okay, I've got this employee, but I want to come in and I want to make it a manager. All right, and when he does this first one, he doesn't use the ES5, ES6 syntax. He uses the old school method of doing it. All right, then he says, you know what? Let's go back and redo it again, and let's do it now using ES6. So I like to go through those 3 examples that he goes through tomorrow. All right, that's what I'm going to start with. Then I'm going to jump back into the chapter, and we're going to go over what's in the chapter. All right. I have no idea if I'm going to have time tonight to grade your tests. I guarantee you they will be done by Friday, because that's the first thing I plan on doing is going over the tests on Friday. All right. And then I want to go over, and I want us to together. I'll give you hard copies, but I want us together to go and write our first simple object-oriented JavaScript application as a class. And not a JavaScript class, but you get the idea. All right? Because again, I think that's how you learn. And if that makes sense to you, that should do nothing but help you when you start going over the assignments for Chapter 16 and when you eventually have that test. And what did we say now? Let me go back here. So, we're now right here, Chapter 16. So, rather than lab all period, I guess I am screwing you, for lack of better words, out of some of your lab time. But I'm going to try to make sure by around 10 each day, might even be a little earlier tomorrow, all right, that you've got time to work on it. So you get at least an hour and a half to 2 hours a day to work on that, all right? But you'll notice again next week, Monday, Tuesday, Wednesday, and Thursday, you do get lab, all period. You break that down, that's almost 4 hours a day, so that's 16 hours. Then a week from Friday, as it says, I'll write up some kind of a pretest. I don't know what it'll be. And again, we will go over the written tests. All right? Then on that Monday, remember this week, that's Thanksgiving week, so we'll only have class Monday, Tuesday, and Wednesday. So on Monday, we'll have the test. Tuesday, we'll go over the test, provided everybody's here and takes it. All right, and I've written the key. And the rest of Tuesday and Wednesday will be lab. Then, once you get back from the break, notice that Monday, Tuesday, and Wednesday, and I'm guessing each one of these lectures will take approximately an hour. All right, the one on 12.1 might take more time. I'd like us to actually build a Node.js project as a class, just so you can see what happens. All right, and then notice that after that, you've got what? Thursday, Friday, Monday, Tuesday, Wednesday, Thursday, Friday, Monday, Tuesday, Wednesday, Thursday. So you've got basically about 10 days, if not more, of straight lab. So in my humble opinion, there is absolutely no reason for you not turning anything in. You've had more than enough time to work on it lab-wise. All right. And again, I have to talk to Mr. Corrigan to see what he thinks about this. But the plan is, not for you two, but for the rest of you and for the newbies that'll be starting in spring, is that I'm going to be lecturing just about every day. Now, that said, I'm not saying I'm going to be lecturing for 3 hours and 50 minutes every day. I couldn't put up with me for 3 hours and 50 minutes per day. All right? But there are going to be probably days when most of the period is going to be lecture. And then I'll just say, now, are there any questions? And if there aren't, I'll say, now, you can work on this. I have no control. You know, if you're at your house and you leave your computer on, unless I ask for people, for comments on this or that, I have no way of knowing if you just left your computer on or you're still there. And to be honest with you, I can't care about that. Maybe that's wrong, but I don't know how I can. You know, it's like if I say, okay, it's lab time, and I'm here now, and if you have any questions, that's what I'll do. And you all will be able to ask questions, So if Mason has a question, hey, I got a question, and everybody can hear him. But it should also be set up, because I think it is with Teams, that if you've got a question, I don't really want to ask this in front of people, you can just send me an email, it'll just be between you and me, type of an idea. But if I think it's important enough, I'd probably answer it in front of the class. Does that all make sense? All right. So you know what we're doing tomorrow, you know what we're doing on Friday, and that'll at least get us through the rest of the week. And lastly, again, you've heard it already, no class Thursday. All right? Okay, that's all I got.